Hello, welcome to the discussion video for functions as power series. In this video, we will answer several exercises on this topic. So before you proceed, please make sure na napanood nyo na yung lecture video for functions as power series para familiar na kayo dun sa mga concepts and techniques na gagamitin natin sa ating mga exercises. Okay? So here is a list of the exercises that we will answer in this video. So hati natin yung video into 3 parts para hindi masyadong mahaba yung pinapanood ninyo. For the first part, we will answer sub-items A to D of number 1. For the second part of the video, we will answer items 2 and 3. And for the third part, we will answer number 4. Okay? So kung gusto nyong subukan munang sagutan yung mga exercises na ito, pwedeng i-pause nyo muna yung video. Tapos balik na lang kayo kapag gusto nyo nang makita yung solution ng mga exercises. Okay? Okay, so let's begin. So for our first example, we are asked to find a power series representation for f of x equals 1 over 2 minus 3x and give the interval in which the representation is valid. So dito, i-recall natin yung strategy na tinuro sa atin doon sa lecture video. So na-establish na natin sa lecture video na ang sum ng geometric series na ito ay equal sa 1 over 1 minus x and nag-hold yung equality na to for values of x in the open interval -1 to 1. Okay? So para lang hindi confusing for us, pinalitan ko yung variable x ng r. So ito yung gagamitin natin para sa mga susunod na examples. So ayun, na-establish na natin tong equality na to. Okay? And nahanap na natin yung condition para mahanap yung interval kung saan siya valid. Okay? So ano ibig sabihin nito? Ibig sabihin, kapag may function tayo of this form, 1 over 1 minus r, pwede nating mahanap yung power series representation niya using this equality. Okay? So yun lang yung idea natin dito. So when we're given a function, itatry natin na isulat yung function natin as the form 1 over 1 minus r. Okay? Para magamit natin yung result na ito. Okay? So para mas maintindihan natin, try nating sagutan yung example na to. So we have f of x equals 1 over 2 minus 3x. Okay? So again, our goal is to write our function as something of the form 1 over 1 minus r. Okay? So para maging 1 yung term na to, you factor out 2 in the denominator to get 1 over 2 times the quantity 1 minus 3x over 2. Okay? So ngayon, paghihiwalay natin yung fractions na ito, we have 1/2 times 1 over 1 minus 3x over 2. And then observe that, itong 1 over 1 minus 3x over 2, ang form niya ay 1 over 1 minus r na. Tama? Where r is 3x over 2. So, ibig sabihin, kapag ginamit natin itong equality na to, we can write this now as 1/2 times the summation from n equals 0 to positive infinity of r raised to n, or r here is 3x over 2 raised to n. And then, ano yung conditions natin for r? So, dapat the absolute value of 3x over 2 is less than 1. Okay? And then, simplifying this, we have 1/2 times the summation from n equals 0 to positive infinity. And then, i-distribute lang natin yung exponent n natin dito sa bawat term. So, we have 3 raised to n, x raised to n over 2 raised to n. And then, we simplify this condition. We get the absolute value of x is less than 2/3. Okay? Since meron pa tayong factor na 1/2 sa labas, pwede natin itong ipasok sa loob ng ating summation. So we have the summation from n equals 0 to positive infinity of 3 raised to n, x raised to n, over 2 raised to n plus 1. Okay, so this series is equal to our function 1 over 2 minus 3x, and this equality is valid for what values of x? So x must be in the open interval negative 2/3 to positive 2/3. Okay? For our next example, we are given f of x equals 1 over 9 plus 4x squared. So, ganun pa rin yung idea, imamanipulate natin yung function natin para masulat siya as 1 over 1 minus r. Okay? So, to do that, so we have f of x equals 1 over 9 plus 4x squared. We will factor out 1 over 9. Okay, so we have 1 over 9 times 1 over 1 plus 4x squared over 9. So observe that hindi pa ito yung gusto nating form kasi dapat minus r to, no? Since plus ito, para maging minus siya, pwede natin siyang isulat as, so 1 over 9 times 1 over 1 minus negative 4x squared over 9. Okay? So ngayon, itong part na to, ang form niya ay 1 over 1 minus r na. Okay? So pwede na natin gamitin yung equality na to. So we have 1 over 9 times the summation from n equals 0 to positive infinity of negative 4x squared over 9 raised to n, and then our condition for x is that the absolute value of negative 4x squared over 9 must be less than 1. Okay? And then simplifying, we get 1 over 9 times the summation from n equals 0 to positive infinity. Again, i-distribute lang natin yung ating exponent sa bawat term. So we have negative 1 raised to n, 4 raised to n, x raised to 2n over 9 raised to n. And then simplifying this, we get 2/3 times the absolute value of x must be less than 1. Okay? Again, since meron pa tayong constant dito sa labas, ipasok lang natin siya doon sa ating summation. We get the summation from n equals 0 to positive infinity of negative 1 raised to n, 4 raised to n, times x raised to 2n over 9 raised to n plus 1. Right? So this is equal to our function 1 over 9 plus 4x squared. And this equality is valid for what values of x? So x must be in the interval, open interval, negative 3/2 to 3/2. Okay? Okay. So for our third example, we are asked to find a power series representation for f of x equals the integral of x over 32 minus x raised to 5 dx. Okay? So paano ba tayo nagpa-perform ng integration sa power series? Well, bago natin problemahin yun, hanapin muna natin yung power series representation ng ating integrand. Okay? So, ganun ulit, try natin i-manipulate ito para masulat siya sa form na 1 over 1 minus r. So, para magawa natin yun, we need to factor out x in the numerator and 32 in the denominator. So, we have f of x equals the integral of x over 32 times 1 over 1 minus x raised to 5 over 32 dx. Okay? And then ngayon, etong term na ito, pwede natin siyang isulat as the summation from n equals 0 to positive infinity of x raised to 5 over 32 raised to n dx. Okay, and then ang condition natin kay x is that the absolute value of x raised to 5 over 32 must be less than 1. Okay? And then, simplify muna natin yung ating integrand. So, we have the integral of x over 32 times the summation from n equals 0 to positive infinity of x raised to 5n over, dito isusulat natin yung 32 as 2 raised to 5. So we have 2 raised to 5n dx. Okay? And then our condition for x is the absolute value of x over 2 must be less than 1. Okay, so dito, kunin nyo lang yung fifth root ng both sides of this inequality. Okay? Okay, and then simplifying further, we have the integral of the summation from n equals 0 to positive infinity of x raised to 5n plus 1 over 2 raised to 5n plus 5 dx. Okay? So ngayon, balikan natin yung ating concern, yung ating question. Paano ba tayo nagpe-perform ng integration sa power series? So dito, ang ginagawa natin, pina-perform lang natin yung integration doon sa term containing the variable. So since we're integrating with respect to x, integrate lang natin yung terms na merong x. Okay? So we have the summation from n equals 0 to positive infinity of 1 over 2 raised to 5n plus 5. Ihiwalay muna natin yung walang x para hindi confusing. And then, integrate natin yung terms na may x. So we have x raised to 5n plus 2 over 5n plus 2. Okay? And then, since this is an indefinite integral, huwag niyong kalimutan yung plus c. Okay? So this is equal to our function integral of x over 32 minus x raised to 5 dx. Okay, so again, dahil ito ay indefinite integral, hindi natin mahanap yung value ni c, no? So, i-leave nyo lang siya as is. Okay? And then, for what values of x does this equality hold? Okay? So, from here, no? Dapat the absolute value of x is less than 2, or x is in the open interval from negative 2 to positive 2. But note here that this interval of convergence is for the geometric series in the integrand. Okay? So, in-apply natin dito yung equality na ito. Okay? Kaya sure tayo na yung interval of convergence nito ay ito. Pero since itong power series na ito ay na-obtain by taking the integral of this geometric series, hindi natin pwedeng i-claim na yung open interval na negative 2 to 2 ay yung interval of convergence din ng power series na ito. Okay? So, ang sinasabi ng theorem, yes, pareho sila ng radius, pero pwedeng hindi sila pareho ng interval of convergence. So, what do I mean by that? Possible kasi na ang interval of convergence nito pwedeng kasama yung endpoints. So, yun yung kailangan pa nating i-check. Okay? So, to verify kung kasama ba yung endpoints sa interval of convergence ng power series na ito, we can check. Okay? So, at x equals negative 2, okay, the series becomes, okay, let's first, ano ba yung series natin? Copyhin lang natin from here. And then paste here. Okay, so this is our series. So when x is equal to -2, our series becomes the summation from n equals 0 to positive infinity of 1 over 2 raised to 5n plus 5 times -2 times 5n plus 2 over 5n plus 2. Simplifying this, we get the summation from n equals 0 to positive infinity of 1 over 2 raised to 5n plus 5 times -1 raised to 5n plus 2 times 2 raised to 5n plus 2 all over 5n plus 2. Okay? Note here that this will cancel, right? And may matitirang 2 cubed sa denominator. Moreover, -1 raised to 5n plus 2. Okay, we can write this as -1 raised to n plus 4n plus 2. Tama? And then we can write this as -1 raised to n times -1 raised to 4n times -1 raised to 2. Ang -1 squared, we know that this is just equal to 1. -1 raised to 4n is also equal to 1. So this is just equal to -1 raised to n. Okay? Therefore, we can write our series as the summation from n equals 0 to positive infinity of -1 raised to n over 2 cubed times 5n plus 2. Okay? And we know that this is an alternating series, right? And by alternating series test, we know that this is convergent by AST, right? Bakit? Since the sequence 1 over 2 cubed times 5n plus 2. So from n equals 0 to positive infinity, this is ultimately decreasing. Moreover, the limit as n goes to positive infinity of 1 over 2 cubed times 5n plus 2 is equal to 0. Okay? So dahil convergent yung ating resulting series when we substitute x is equal to -2, ibig sabihin, yung -2 ay included doon sa interval of convergence of this power series. Okay? Ngayon naman, check natin for the other endpoint. At x equals to okay, our series becomes the summation from n equals 0 to positive infinity of 1 over 2 raised to 5n plus 5 times 2 raised to 5n plus 2 over 5n plus 2. This will cancel and then may matitirang 2 cubed sa denominator. Simplifying, we get the summation from n equals 0 to positive infinity of 1 over 2 cubed times 5n plus 2. Okay, we can reindex this. So we can write this as the summation from n equals 0 to positive infinity of 1 over 2 cubed times 5 times n minus 1 plus 2. Sorry, this should be n equals 1. Okay? Para mas madaling makita that this is divergent by limit comparison test using the harmonic series. Okay? So, i-verify nyo na lang ito. Okay? So, ibig sabihin, kung divergent siya when x is equal to 2, then hindi kasama yung 2 sa interval of convergence ng ating power series. Hence, so balik tayo dito. Hence, we were able to show that negative 2 is included but 2 is not. Okay? So, ang interval of convergence ng power series na ito ay this interval negative 2 to 2, where negative 2 is included and 2 is not. Okay? So for the fourth item, under example 1, we want to find a power series representation for f of x equals x squared over the quantity 16 plus x squared, and give the interval in which the representation is valid. So dito, hindi gagana directly, no? Yung strategy natin kasi mahirap ito express as something of this form. Tama? Kasi naka-square yung denominator. But observe that, kung i-examine natin yung function natin, mukha siyang related sa derivative ni 1 over 16 plus x squared. Tama? So we can check what is the derivative of 1 over 16 plus x squared. So this is equal to negative 1 over 16 plus x squared, and then chain rule, differentiate 16 plus x squared, we have 2x, or we have negative 2x over 16 plus x squared. Okay? So ang idea is, para magamit natin ito, kailangan natin i-express yung function natin as something of this form. Okay? Times some function. Siguro. Okay? So observe that we can write f of x as, so this is x squared over the quantity 16 plus x squared. Kung gusto nating palabasin ito, so we have negative 2x over 16 plus x squared. Ano na lang yung matitira? Okay? So dapat mag-multiply tayo dito ng negative x over 2. Okay? And then, etong term na ito, itong factor na ito, pwede natin siyang isulat as the derivative of 1 over 16 plus x squared. Okay? So, i-rearrange ko lang para hindi confusing. So, we have negative x over 2 times the derivative with respect to x of 1 over 16 plus x squared. Okay? And then, kung i-observe natin ito, pwede natin siyang i-transform to something of this form. Tama? So, doing that, we have negative x over 2 times dx, the derivative with respect to x of 1 over 16 times 1 over 1 minus negative x squared over 16. Okay? And then, itong factor na ito ay already of the form 1 over 1 minus r, where r is negative x squared over 16. So, pwede natin gamitin yung result na ito. Okay? Okay, let me copy this first. Okay? And then, itutuloy natin yung ating solution. So, we have negative x over 2 times the derivative with respect to x of 1 over 16 times the summation from n equals 0 to positive infinity of negative x squared over 16 raised to n. And what is our condition for x? The absolute value of negative x squared over 16 must be less than 1. Okay? And then, simplify muna natin yung nasa loob ng ating bracket. So we have negative x over 2 times the derivative with respect to x of the summation from n equals 0 to positive infinity of negative 1 raised to n, x raised to 2n over 16 raised to n. Dito, let's write 16 as 4 squared. Okay lang? So this becomes 4 raised to 2n, no? And then, ipapasok natin yung 1 over 16 sa loob ng summation. So we will have 4 raised to 2n plus 2. Okay? And here we have the absolute value of x over 4 must be less than 1. Okay? Now we're ready to differentiate this power series. So let's recall na kapag nagde-differentiate tayo ng power series, ang ginagawa lang natin ay dinidifferentiate lang natin yung terms containing the variable. So in this case, since we're differentiating with respect to x, i-differentiate lang natin yung terms ng ating power series containing x. So in this case, itong x raised to 2n. Okay? So we write this now as negative x over 2 times the summation from n equals 0, okay, to positive infinity of negative 1 raised to n times times 2n times x raised to 2n minus 1 over 4 raised to 2n plus 2. Okay. I apologize. This should be equal to 1. Okay? Anong palatandaan natin, guys, para malaman natin kung kailangan natin mag-reindex after performing differentiation? Okay? So, ang palatandaan lang natin ay i-check nyo yung exponent ng x. Okay? Dun sa nakuha ninyong resulting power series after nyo mag-perform ng differentiation, i-check nyo yung exponent ni x, tapos dapat hindi ito magiging negative. Okay? So, piliin nyo yung least value ni n such that this is non-negative or this is 0. Kasi if n is 0, we will have here 0 minus 1. So, we will have x raised to negative 1. Pero hindi yun possible. Okay? So, dito, kailangan yung index natin mag-start sa 1. Okay? Okay. And then, the condition for x is that the absolute value of x must be less than 4. Okay? Simplifying this further, so ipapasok lang natin yung factor na ito sa loob ng ating summation. So we have the summation from n equals 0, n equals 1 to positive infinity of negative 1 raised to n plus 1. Tama? Kasi may negative ka dito pinasok natin. So magiging n plus 1, may exponent. And then we have 2n times x raised to 2n minus 1. Magiging 2n na lang. Dahil may x tayo dito. Over 2 times 4 raised to 2n plus 2. Okay? Here, itong 2 ay magka-cancel. So this is our power series representation for this function. Okay? And yung possible na interval of convergence nito ay yung open interval negative 4 to 4. So again, tulad nung previous item, since nag-perform naman tayo dito ng differentiation, okay, so kailangan natin i-check kung included ba yung endpoints sa interval of convergence ng power series na ito. Okay? So to check the convergence at the endpoints, we just substitute. So at x equals negative 4, the series becomes, okay, let me copy this first. Sorry, don't mind this. And so the series becomes summation from n equals 1 to positive infinity of negative 1 raised to n plus 1 times negative 4 raised to 2n over 4 raised to 2n plus 2. Sorry, we have a factor of n here. Okay? Simplifying this, we get the summation from n equals 1 to positive infinity of negative 1 raised to n plus 1 times n times negative 1 raised to 2n times 4 raised to 2n over 4 raised to 2n plus 2. Okay? Note that this is just equal to 1. Tama? And this will cancel. May matitirang 4 squared sa denominator. Okay? And then simplifying, we get summation from n equals 1 to positive infinity of negative 1 raised to n plus 1 times n over 4 squared. Okay? And we know that this is divergent by divergence test. Tama? Since the limit as n goes to positive infinity of negative 1 raised to n plus 1 times n over 4 squared does not exist. Okay? At the other endpoint, so at x equals 4, the series, okay, so the series becomes summation from n equals 1 to positive infinity of negative 1 raised to n plus 1 times 4 raised to 2n over 4 raised to 2n plus 2. And again, may factor tayong n dito. Simplifying, this is equal to the summation from n equals 1 to positive infinity of negative 1 raised to n plus 1 times n over 4 squared. So, kamukha lang siya nung nakuha nating series doon sa other endpoint. So, this is also divergent by divergence test. Okay? Therefore, ano yung conclusion natin? Dahil parehong divergent yung resulting series of constant terms na nakuha natin when we substitute the endpoints, ibig sabihin, hindi kasama yung endpoints sa ating interval of convergence. So, i-leave lang natin as is na open yung interval na ito. Okay? So, this is the power series representation for our f of x. Okay? And this is the interval of convergence. Okay? So, I hope that's clear. So, ika-cut muna natin yung video hanggang dito. And I'll see you on the second part of our discussion video for functions as power series.